Hey guys, I hope you're all well. Today we're going to walk through the Further Pure Maths 1 AS exam. So this is from the May-June 2018 exam series, but this is only the AS exam. Okay, so if you sit in Further Pure 1, you might find this is some good revision. So we're going to go through every question here, so let's jump straight into it. So the first question here is a T substitution, or T-Formula question. So let's have a go. So we've got to use the substitution t equals tan x over 2 to show that the equation 5 sin x plus 12 cos x is equal to 2 can be written in this form. The first thing I'd always do with a question like this is write out the substitution. So, oh, my pen's very big. Should we try that? I want one more. Okay, let's clear all this then. Right, there we go. So sin x, what would that be? Well, that would be, so you should just kind of memorise these. You can derive them in the exam, but I'd just memorise them. You want to save yourself time in the exam. You don't want to be panicking about trying to derive these. And they're actually quite easy to remember. So if you remember sin x equal to 2t over 1 plus t squared, obviously we're only dealing with sin and cos for this question, so you'll need to write sin and cos. Cos x is very, very similar. Same denominator, so 1 plus t squared. The numerator is just a reciprocal, so it's 1 minus t squared. So that's a nice way to memorise them. Okay, so as long as you can remember sin x is 2t over 1 plus t squared, cos x isn't too bad. So we know which substitutions we're using here. We've got them in terms of cos x and sin x here, in terms of the t substitutions. So all we need to do now is use this equation here with these substitutions. So we can write that now as 5 lots of 2t over 1 plus t squared plus 12 lots of cos x here. Okay, and we know this is equal to 2. So the good thing here is that because it's sin x and cos x and the t formulas are these, with it being 1 plus t squared in both denominators here, what we can do then is just simply write this over a common denominator. So 5 times 2t, so that's 10t. 12 times 1 minus t squared, so that's 12 minus 12t squared. And we write it over this common denominator. Like so. And this is still equal to 2. This hasn't gone anywhere. And now at this stage here, we want to get rid of this denominator. So how can I do that? Nice and easy, just times 3 by 1 plus t squared, right? So I'll get the numerator on my left hand side, and the right hand side is 2 times this denominator. So if we do that, plus 12 minus 12t squared is equal to 2 plus 2t squared. And at this stage here, it's just simply rearranging. So with it being 7t squared here, notice I've got minus 12t squared. So if I add 12t squared to both sides, I'm going to get 14t squared. So what it's looking like here is the link is just dividing through finally by 2. So if I add, basically if I take everything onto this side here, I'm going to get 14t squared. I'm going to get minus 10t and then minus 10. This is equal to 0. And notice each one of these is just basically what we need to write, but times by 2. So if we divide by 2, so divide by 2, we get 7t squared minus 5t minus 5 equals 0 as required. Okay, so that's part A there, just to get us started. And then part B, we're going to try and solve this. So for part B, if you're struggling to get part A, don't worry too much. You can just start part B even without part A. So why is that the case? Well, they've given you what the required form is. So we can use this. If we try and factorise this, I'll just use the quadratic formula, we'll get a solution. So if you try and factorise this, what you'll find is that you actually can't factorise it, okay? A bit of a nasty one. So we're going to have to use quadratic formula to do this one. So what we're solving for here is t. So using quad formula, what we get here is t equals 5, so it's minus b, so minus 5, plus or minus the square root of b squared, so 25 minus 4 times a, which is 5, oh sorry, which is 7, and then we times it by c here, which is minus 5, so that's where the minus 5 comes from. We divide this by 2a, where a is 7, so 14. And if we simplify all this, what we're going to get here is t equals 5 plus or minus root 165 divided by 14. Okay, so really what we should do here is take tan inverse of this. So you take tan inverse of the positive, 5 plus root 165 divided by 14, and then do the same with the negative, so 5 minus this. You can actually get away with this one by working each one out individually and then just doing tan inverse, but just to save time, I'll just write it as I would. So x over 2, it's going to be equal now to tan inverse of this with the positive one. So that's what that's going to look like. We're also going to do it for x over 2 is equal to tan inverse of 5 minus root 165 divided by 14. Okay, so each one here we're going to get two individual solutions. So for this one first, we get x over 2 is equal to 51.8849, so on and so on. So just to get x here, and it's still within our range, times this by 2, so we're going to get 103.8 degrees, and do the same here. This gives us x over 2 is equal to minus 29.265, so on and so on. And then if we times through by 2, we get x equals minus 58.5 degrees. Okay, so that's the first question there. Moving on to question 2 here, we've got a simple, again nothing too crazy going on, differential equation question which we're going to solve using numerical methods. So we're using 2 iterations of the approximation formula given here to estimate the temperature of the coffee 3 minutes after it was put in the room. So this is a really interesting question. You know, you can trust Edexcel to give you these good questions. So let's have a go at solving it. So question 2 here, part A. So if you're not given the h, the step value, this is something you should work out at the start. So we're not actually given it for this question, so we need to work it out. So we're going from the initial time, so time 0, to time equals 3 minutes. Okay, that's essentially what we're looking at here. So if you're going to do it in 2 iterations, so 2 steps, you can kind of figure out that it's got to be 1.5. So that would be one way to do it, so h would be 1.5. Or we'd be doing 3, but we want to end up at minus 0, that's what we're starting at, divided by 2 iterations. So 3 over 2, so h equals 1.5, right? So that's one way to do it. So now we've got h, what we need to do now is work out d theta by dt with our initial value. So what we've got here is theta 0 is equal to 8 degrees, so just 8 in this case. So we're going to use k equals 0.1. So what we can do now is work out dy by dx at 0. Essentially, in our case, it's d theta by dt. So I'm going to write everything kind of, really in kind of this approximation form. It might make a bit more sense in a minute. So let's just work out d theta by dt. So what's that going to be? Well, that's going to be minus k, so minus 0.1, times theta, which is 80, minus 20. So this is minus 0.1 times 60, so we get minus 6 here. Okay. So now, using approximation, the approximation, we want to rearrange this. So what we want is y1, that's our next step. That'd be basically after 1.5 minutes, or 1.5 minutes, I should say. So if we rearrange this in terms of y1, what would that be? Well, that'd be y1 is equal to h times dy by dx at time 0, or the initial condition. So dy by dx at 0 plus y0. Okay. and our y0 will be this here. So if we do that for hours, what would that give us? Well, that's going to give us h, which is 1.5, so 1.5 times dy by dx at 0, so that's essentially our d theta by dt, so that's going to be minus 6, and then we add on y0, which is a. Okay, if we work that out, so this is y1 is equal to this. If you work this out, essentially this is minus 9 plus 80, so 71. Okay, and now we're just going to repeat the process. Have I got enough room down the rest of the page? No, it's coming down with me anyway. Let's just clear it. So we've got the first one here, theta 1 now is equal to 71. So now let's work out dy by dx at the next step, so 1. So essentially this is our d theta by dt at 1. So what would that be? Well, that'd be minus k again, so minus 0.1 times theta 1, which is 71 minus 20. And if you work this out, you should get that this is 63.35 here. Okay, so now we need to work out y2. So again, just using a rearrangement of this. So y2 is going to be h times dy by dx at the next step, which is 1. So that's going to be, I don't want to keep doing that bracket. So it's going to be 1.5 times minus 5.1, and then whoa, okay, I made a mistake. This isn't going very well. I'm actually writing down the answer here. So this is not 63.35. This is minus 5.1. So I'm getting carried away with my calculations. This is minus 5.1. So yeah, so 1.5 times d theta by dt, so that's minus 5.1, and then we add on theta 1, so plus 71, and then if you work that out, that is what we just got there, so 63.35 degrees Celsius. Okay, so getting carried away with my calculations, don't do that in your exams. Part B, so we're just told that it had an initial temperature of 80 when it's put in the room, but it cools more slowly. So what information, or using this information, what would we suggest for the value of k? So all you need to say for this is that we just need to decrease, so just decrease k to a smaller positive value. So it's important that we make note that it's a positive value. And that's simply all you need to say, smaller positive value. Okay, which need to take into consideration the model that we've got. So that's question 2 done. Moving on to question 3 now, we have a question here dealing with inequalities. So like we can see here, we've got x over x squared minus 2x minus 3 is less than or equal to 1 over x plus 3. So we have to use algebra, so we can't really use a graphical method to solve this. So let's take this step by step and see if we can break it down. Now, dealing with inequalities like this, the big issue here is dealing with kind of how the inequality works. So for example, we don't know, obviously due to the fact that we've got x's here, whether when we times through by something, whether it's going to be positive or negative. So the way we deal with that is timesing through by, for example, x plus 3 squared. Because if you square anything, it'll always be positive. So let's take this left-hand side first. What I'm going to do is factorize this. So x squared minus 2x minus 3, so that will be x minus 3, x plus 1. Okay, so that's what that is that's my denominator. So what we do is we times the left-hand side by x minus 3 squared, x plus 1 squared, and we times it by this denominator also squared. So writing that out in full. And then we also times it by x plus 3 squared. For now, we still write the denominator in. So that's x minus 3, and then x plus 1. This is less than or equal to, again, do the same with the right-hand side. So we're going to times it by x minus 3 squared, x plus 1 squared, and then x plus 3 squared. So we can write that as x minus 3 squared, x plus 1 squared, and then finally x plus 3 squared. Okay, we're kind of running over onto the grey bit here, but hopefully you can still see. And we divide this by x plus 3. So at this stage here now, what we're going to start doing is cancelling. And we're going to basically set this equal, well, less than or equal to 0. So first let's just cancel. So x minus 3 squared divided by x minus 3 times x plus 1. So one of them will cancel with one of them. One of these will cancel with one of these. Can't do anything with this in terms of the left hand side. Right hand side here, we've just got an x plus 3. And we can cancel with that one there. Okay. So what we've got now, if we just write out just so we can see, got x lots of x minus 3 times x plus 1 times x plus 3, which is less than or equal to x minus 3 squared times x plus 1 squared times x plus 3. Okay, so at this stage here, don't be put off by the fact that we've got so many brackets. Everything will work out quite nicely. So at this stage here, to make life easy, I want to set this less than or equal to 0. So if I take this whole right hand side and take it onto the left hand side by just subtracting it, so what do we get? Well, we get this minus this, so trying it out in full again. And the reason we do this is that we can factorise it and then just start basically setting it out in terms of, in this case, it'll actually work out as a quartic. So, if I look to factorise this now, well, we've only just got this x here, we don't have any x's here. We've got an x minus 3 here, we've got x minus 3 squared, so we can apply at least an x minus 3. We've got an x plus 1 here, we've got x plus 1 squared, so we can also apply at least 1x plus 1. We've got x plus 3, and we've got x plus 3 here. So, I've made a mistake, sorry, that should be x plus 3 squared. It should be x plus 3 squared, so I'm glad we noticed it now. So I can apply an x plus 3. Okay, so now, that's what we've factorised out. So what do we times this by to get this? We need this x, that's what we're missing still, and we're also missing an extra lot of x plus 3. So that's that side here dealt with, or that part of it. This part now, what would this be? Well, we need an x minus 3, so that's going to be minus x minus 3. And we also need, from this to get this, we also need an x plus 1. Like so. Here now, what we do is we just deal with this square bracket here, so simplify this. So for example, if you start dealing with that, you're going to get x minus 3, x plus 1, x plus 3. So that'd be x squared plus 3x. X squared plus 3x. So this would be x times x, so that'd be minus x squared. What else would we get? We get plus 2x, because it'd be x times 1, so that's x, minus 3 lots of x, that'd be minus 2x, because it's minus, we get plus 2x, and then we also get plus 3. It's less than or equal to 0. The x squareds will just cancel with each other. 3x plus 2x is 5x, and we get plus 3. So now what we've got is we've got this quartic here, x minus 3, x plus 1, x plus 3, and then finally we've got 5x plus 3. And this is less than or equal to 0. And now this is looking much better. So here now, you need to consider your critical values. So, considering the critical values here, what would they be? Well, we'd have this one here, minus 1, we'd have minus 3. So let's just write it from minus 3, minus 1. We'd also have this one here, so this would be 5x equal to minus 3, divided by 5, we get minus 3/5. And we're also going to have this final one here at 3. So, for a question like this, I'd always recommend drawing a sketch. The question asks us to use algebra, and up to now, we've used algebra perfectly. But just to get an idea of where this actual region is that we're looking for, we're going to draw a sketch. So I'm going to do it in pink. I think this is pink, right? Just to get an idea of what's going on. Again, it doesn't have to be anything perfect. So what are we looking for? Well, it cuts through at minus 3. Let's just say that's there. It cuts through at -1. Say that's there. Cuts through at -3/5, so let's just say that's there. And it also cuts through at 3. So we say that's there. Now remember, for a quartic graph, and it's a positive quartic, it's going to start in the top left over here and finish over here in the top right. You can, well, if you've got a graphical calculator, you could put this on your graphical calculator and get an idea of what it's going to look like. But if you actually just sketch this, what it's going to look like here is something like this. So again, my art skills are pretty terrible. And just to make note of where it cuts through, -3 times 1 times 3 times 3, it cuts through at -27. So we say that's there, cuts through there, and comes back up like that. Okay, so obviously my coordinates are kind of all over the place here. So -3, -1, -3/5, and 3. What we're actually looking for then is, where is this less than or equal to 0? So basically, where is it under the x-axis? Well, it's underneath here. So if we just do this in a different color just to illustrate it, it's underneath here. And then hopefully you can see that's also underneath here. Okay, so we just need to identify those two regions. So you can give your answer in a couple of different ways. You can use set notation if you'd like, or you can just literally write out the inequality if you prefer. I will use set notation, and I would recommend that you always try and do it in set notation, because you can sometimes be asked to give the answer in set notation. So if you just learn how to do it for all of them, you're not ever going to have an issue with it. The only thing we have to be very careful of is for which values, in terms of these critical values, is this inequality here undefined. Well, consider your factors here, so x minus 3, x plus 1, and x plus 3. So for example, if x was 3, this left-hand side would be 0, it'd start causing issues. Right-hand side, if x is -3, that would cause us issues. And again, if x is -1, causes issues. We don't want any zeros, basically. So, obviously, we'd end up with an issue of dividing by 0. And that's just going to cause us a world of pain. So to avoid that, sometimes they will give these for you. Here, essentially, I'm just going to say x can't be equal to -1. Also can't be equal to -3. And it can't be equal to +3. Okay? And the reason that's important is because now when we write our solution, so x is a real number. So the first range here is from -3 to -1. And then obviously, because we've said x can't be -3, this is a strict inequality here. So strict again here, -1. Or it would also be satisfied between here, which is -3/5 to 3. But again, we can't have it being at 3, but the -3/5, that's not a problem, okay, because it's not involved in this actual inequality here. So we'd write that again. X belongs to the reals from -3/5, and we can include that value to 3. Okay, we can't include that 3. And there we have it, so that's our final solution there for question 3. Moving on to question 4 now, we have a question here dealing with vectors. So, we've got this question here in context, where basically we're looking at something, basically looking at a crystal or some garbage like that, where we've got these 4 vertices, so A, B, C, and D, and we're told the math, which we'll need later on for part B. But for part A, we just have to show that the area is 52.2 millimeters squared. So, for a question like this, it's worth just jotting down the formula that we're going to need. So the formula we need, area, that is just half of the determinant of, or the cross product of AB crossed with AC, like that. Okay. So now, what we can do is we can work out AB, we can work out the vector AC, and then we can just use this formula to work it out. So let's just write down AB first. So what's AB? Well, the vector AB is B minus A. So for example, 10 minus 12, that's my new I component. So 10 minus 12, so minus 2. 15 minus 4, so that'd be 11. And then finally, minus 3 minus minus 1. So minus 3 plus 1, giving me minus 2 there. Okay, and if we work out the vector AC, all we need to do then is work out the cross products of these two, and then just work out the length here, and times it by a half. So the vector AC is C minus A, so 5 minus 12, 8 minus 4, and then finally 5 minus minus 1. Okay, so we've got our two vectors here. So what we're actually working out here now is half of, in fact, let's just work out the cross product first. So the cross product, that's I, J, K. So my first vector is this one here, AB. And then we'll put this vector underneath. And obviously, if you notice, all I'm doing is matching up the i's. So the i's, minus 2, minus 7, the j's, the 11 and the 4, for example. Okay, so working this out now. If you're not too sure how to do this, it's not actually too complicated. So imagine you cover up the first row and the first column, and we're taking I lots of this. So this is I lots of. So all we get left with, if you cross that one out, we get 11, minus 2, 4 and 6. So you're working at the determinant of this 2 by 2 matrix. So that's 66 minus 2 times 4, so that's minus 8, so minus 8, so we're plus 8 to it. Okay. The J one now, so this would be minus J, so imagine we cross this row out and this column, because that's the one we're working with. So it'd be minus J lots. So all we get left with is the minus 2, the minus 2, the minus 7 and the 6. So minus 2 times 6 is minus 12. And we get minus 2 times minus 7. So just be very careful with your signs here. That will be minus 14. Obviously, minus 2 times minus 7 is 14, positive 14, but you're minus in it, so minus 14. And then finally, we've got the K component here. So we're getting rid of this row, this column, so we just get left with this bottom left determinant. So you're just working that out. Now, this shouldn't be too bad. Plus 77 there. Okay, so working out each one individually, what do we get? Well, what I'm going to do is I'm going to write this in vector component. So that would be 74, 26, and then 69. Okay, that's my vector there. So what we need to do is we need to work out the length of this and then times it by half. So we're working out half of 74 squared plus 26 squared plus 69 squared. Plug this onto your calculator, and this is a half of 104.465 blah blah blah. But if you work this out, you get 52.2 millimeters squared as required, right? 52.2. We've got 52.2 as well. So that gets us the first 3 marks there. Part B. So we're asked to find the density of the crystal. So if we need the density, well, to work out the density, we need the volume, right? So let's just clear all this. So the first thing to know is we need to find the volume. So we need to find the volume of A, B, C, D. Right, so we need to find this volume. Now, there is a couple of different ways you can do this, and there's a few different ways you can perform the calculations. There is one way that is technically the best, only because we've kind of used a bit of the information in part A. But I'll just write down two different ways you can do it, just so you're aware of it. So, to actually work this out, we need to use the cross products again. So, like I said, this way, just a couple of different ways you can do it. For example, I could simply calculate this volume, so V is being now the length of the vector AD dotted, so using the dot products here, of AB crossed with AC, for example, right? That'd be one way I could do it. And this would be ideally the best way to do it, because we've already worked out AB crossed with AC. We did that in part A, right? If you remember, we were finding the area. Another way you could do it, and I will technically have to times this by 1/6 as well, so it'd be 1/6. for the volume of the tetrahedron. Another way is I could do, for example, AB, so the vector AB, dotted with the cross product now of AC by AD. That'd be another way of doing it. And there's a couple of other ways you could do it as well. But for me here, for this one, we'll use this method. This is the best way, because we've already worked out AB crossed with AC. So what we need to do is work out the vector AD. We're going to dot it with AB crossed with AC, and then just start performing all this. So, AD, so the vector AD, let's work that out. So, D minus A, so what's that going to be? That's going to be 2 minus 12, so that's going to be minus 10. 2 minus 4, so minus 2, and then finally minus 6, minus 1, so just add 1 to minus 6 to get minus 5. Okay, so that's the vector AD. So, because we already got AC crossed with AD, we're just going to use this one here. So, plugging all this in now, what we want to do is dot AD, so that's this, with AB crossed with AC. So if you remember, we did that in part A, which if you can't remember it, or you haven't written it down yet, that was 74, 26, and 69. Okay, so now if we work at the dot product here, what would that give us? Well, minus 10 times 74. So what I'm actually going to get here is we need the length of this. This is the length of minus 740. Minus 2 times 26, that's minus 52. And then finally, minus 5 times 69, minus 345. Okay. Simplify this here. So minus 740 minus 52 minus 345. So that will be minus 1137. So essentially, you just be squaring this and taking the square root, and then you're going to times it by 1 over 6. So essentially, V is 1 over 6 times 1137, like so. And if you work this out, this comes to 189.5 millimeters cubed. Okay, so that's the volume in millimeters cubed there. Now, the difficulty here is we need the density, so we're not done just with the volume, and we also need to give it in grams centimeters to the minus 3, right? So how do we do that? Well, we need to use the fact that the density, so D is equal to mass divided by volume. So just kind of relating some of the the facts that you would have learned at GCSE maths or science, for example. So density is equal to mass divided by volume. So the mass is 0.5. So this is 0.5 divided by the volume. And now the volume we've worked out to be 189.5 millimeters to the power of 3, or 189.5 millimeters cubed. But we need it in centimeters. So what we've got to do here is, well, either divide it by 1,000 or times it by 1 over 1,000. So if I write that out, that's going to be 189.5 times 1 over 1,000, like so. Okay, so I'm getting a bit messy here, but if you perform this calculation, so 0.5 divided by 189.5 times 1 over 1,000, so just right up here, density is 0.5 divided by 189.5 divided by 1,000. Okay, calculate that, and what you'll get is 2.6 G to cm, or cm to the minus 3. Okay, and there we have it. So that's question 4 complete. I'm moving on to the last question here, question 5. We're dealing with conic sections and rectangular hyperbola. So 2 parts of this question. Part A, a very, very standard question, just finding the equation of a normal, and then part B, just slightly a bit more complicated, just a bit of geometry work here. So let's have a look at this question. So let's start with part A, obviously. So again, like I said, very, very standard question. If you find these questions difficult, at least just try your best to ensure that you're confident with the equation of the tangent and equation of the normal for these type of questions. So the first thing I've got to do here, or consider, is the fact that because we want to look at the equation of the normal, we're going to need the derivative. The reason we need the derivative is to work out the gradient, and then obviously because it's a normal, we'd have to work out the perpendicular gradient. So let's just start by getting the derivative. So if we put this in terms of y here, so xy is equal to c squared. That means y is c squared divided by x. Or in other words, so c squared divided by x, we can also write that as c squared x to the minus 1. Okay, this way is slightly easier to work with when we differentiate. So if we differentiate this now, so don't be put off by the fact that there's this c squared here in front of the x to the minus 1. Like it says here, c is just a non-zero constant. So it's essentially just a number. So if you just differentiate this like normal and treat this like a regular number, it makes the differentiation much easier. So this would be minus c squared. Take 1 off the power, so x to the minus 2, and then we're going to do, and then we can rewrite this actually. So we can write this as minus c squared over x squared, right? So that's another way we can write it, and we'll write it like this because what we're going to do now is substitute in our x coordinate here to work out the gradient. So dy by dx at p is just subbing in cp here, so that's going to be minus c squared divided by x squared, where x squared is cp, so that's c squared p squared. Okay, so hopefully that's clear there. Just squaring cp to get c squared p squared. And then at this point here, we can just cancel quite nicely. C squared, cancelled there. All I get left with is minus 1 over p squared. But remember, this would give us the gradient here if we work out the equation of the tangent. Because it's the equation of the normal, we need to work out the perpendicular, the negative reciprocal. So the gradient for the normal here will be just p squared. So imagine you take the reciprocal and then times it by minus 1. We just get p squared. So now all we've got to do is use y minus y1 is equal to m times x minus x1. And we're just going to use the coordinate here for p. So now, what's that going to give us? Well, that's going to be y minus y1, where y1 is c over p. This is equal to p squared here times x minus x1, where x1 is cp, like so. So what can I do here? Well, the first thing I can do is just expand this here. So this would be y minus c over p is equal to x. Should I write as xp squared? I should probably write as p squared x minus cp cubed. Okay. Next thing I can do is I can times through by p to get rid of this denominator. So what I'm going to do is I'm just going to do it in blue now. Do it up at the top. So timesing through by p, I get py minus c over p. This is equal now to p cubed x minus cp to the 4. Okay, like so. And then at this stage here, oh, that should have gone. What am I doing? Head's not with it. Right. So, like so there. That's much better. So py minus c, that's equal to p cubed x minus cp to the 4. Okay, that's good. So everything's fine. I've not made any more mistakes. Now at this stage here, if you notice what they've got p cubed x. We've got p cubed x. They have a minus py. We've got positive py. And then this part here looks like it's just going to be a bit of factorisation. So what I'm going to do is, seeing as that this p cubed x is positive and it's positive here, just take everything onto this side. Okay. So p cubed x minus py plus the c and minus cp to the 4. So this part here now, this should be equal to 0. This part here now, this looks good. This is what we wanted. If you notice in the question, this bit here we can just factorise like so. And what can we factorise out? We can factor out this c here. So that's going to be 1 minus p to the 4 there, which is equal to 0, as required. So like you can see, there is a bit of work with it still, but I think the concept is quite simple for the most part. So you always work out the derivative, subbing your point that you've got, and then basically just get your gradient, and then just sub your point back in and just simplify until you get what they give you. That's always kind of the same standard idea there with that one. Now part B, we're going to have to clear this because it's quite a long question. Definitely one of the trickiest parts of this paper. So we're told the normal to H at the point P meets H again at the point Q. So all we want to do is find the coordinates of the midpoint of PQ. So where can we begin with this? Well, first let's write this as y equals c squared over x like we did before. And what we can do is we can substitute this point in, because what we're essentially looking for here is to obtain a quadratic. And what you will find for one of the points is that you get this x coordinate here. Because what we'll do is we'll end up with our points being in terms of x. So if we substitute in for y, we're going to get it in terms of x, factorise, get our other coordinate there, and then we can just work out the midpoint simply at the end. So y equals c squared over x. So using this here, and again, if you couldn't get this, you can carry on with part B. So that's going to be p cubed x minus p times y, so minus p times this, like so, plus c, lots of 1 minus p to the 4. This is equal to 0. So now at this stage here, what I'm going to do is I'm going to times through by x, get rid of this denominator, and just multiply out this part here. So this will be p cubed x squared minus p c squared. I mean, this should really be c squared p, doesn't matter though. Plus cx 1 minus p to the 4. This is equal to 0. Okay. So at this stage here, everything's good. So going from here now, what I can do is start simplifying. Because remember, what we want to do is obtain a quadratic. And once we've got that quadratic, we can get that x coordinate, then we can substitute back in. So let's see if we can, factorise from here. And it might make life a bit easier if we write this just kind of a bit more in the correct form, I should say. So p cubed x squared, because if you notice, we've got the x squared here, and we've got this x term here. So if I write that in the middle, 1 minus p to the 4 minus p c squared equals 0. So this is essentially x squared, that's your coefficient. I've got this part here for x, where technically your coefficient is c 1 minus p to the 4, and I've just got my c term here at the end if it's a quadratic. So let's see if we can factorise this. Like we said before, what we should expect is that one of the terms is this cp, one of the coordinates. So what I'm going to do then is write this in terms of x minus cp. Then obviously this one would also have to be in terms of x, but it won't just quite be as simple as x. Remember, this needs to be x times something, gives me p cubed x squared. So it's got to be an x there, but there's going to have to be something else with that x. So what would I have to times it by to get the p cubed? Well, clearly just p cubed. So p cubed x. And then finally, what must this bit be? Well, minus cp times something will give me c squared p. So in other words, that just also has to be plus c there, if that's negative. Okay, minus cp times c, we get minus c squared p, or minus pc squared. So that's in terms of 0 now. So what we can do is we can just write our solutions for x. So therefore, x is either equal to cp, which we don't want, we've already got that point, so we don't need it, or x is equal to minus c divided by p cubed. Okay. Have I done that right? Have I made a mistake? No, that's fine. Minus c over p cubed. So now we've got the x coordinate, we can simply work out the y coordinate using this. So y is equal to c squared divided by x, and for our part here, x is minus c over p cubed. Like so. So if you simplified this, this would be c squared times minus p cubed over c. Okay, So one of them will cancel with that one. So what I'm going to get left with here is minus CP to the 3. Okay, so that's my y coordinate there. So what we've just worked out there is the point Q. So Q, if we write this in a different colour now, Q is, what was my x? Minus C over P cubed. And then y was this minus CP to the 3. We know what P is, we got that at the very beginning. So P is CP, C over P. And then at this stage here, we've got all the work. Now we've just got to apply the final part. So the midpoint. So remember, the midpoint is, you know, nothing too crazy. Imagine these were just two different numbers. So for example, that was 3, that was 5. The midpoint for the x coordinates would be 3 plus 5 divided by 2. Just because in terms of these variables C and P here, it doesn't change anything. The method is still the exact same. So the midpoint would simply be CP plus minus C over P cubed. So in other words, I can write that as CP minus C over P to the 3, and then we'd divide it by 2, we'd half it. Okay. Do the same for the y coordinates. So C over P minus CP cubed divided by 2. But this looks a bit messy. We can write in a slightly nicer way. But this would be absolutely fine. Well, actually, we can simplify this. So, no, we can't quite give it like this. So if we simplify this, we can play a half here at the beginning of each one. That would be a half of CP minus C over P cubed, like so. So that's my x coordinate there. And then my y coordinate, again, plate the half. It's going to be C over P minus CP to the 3. Okay, slightly running out of room, but you get the idea there. So that's our final solution there. So a half, bracket CP minus C over P cubed, and then that's your x coordinate. And then your y coordinate is a half, bracket C over P minus CP cubed. So that brings us to the very end of this paper. I hope it's helped. If there's any issues, any mistakes, please just let me know in the comments down below. And if it's helped, please subscribe, guys. Cheers.